Okay, class, today we're going to be doing You Have the Power. So let's look at the first problems at the top. So 4 exponential equations are written below. So what do these equations have in common? Okay, if you said that they are all written to the x power, that would be correct. All the equations have a variable of x in the exponent. So what would this look like if we wanted to solve these equations for x to rewrite it? So if I rewrite it in logarithmic form, I'm going to have log base 2 of 20 equals x. Log base 10 of 48 equals x. Log base 0.8 of 4 equals x. And log of 2.718 of 60 equals x. Yes, I should have said base there. Now, looking at these 4, which one could I solve automatically with the calculator? If you said this one, you are correct. Because why? That is correct. Because it's in the common log. So I can know that I can plug that in my calculator and I'll get that it's log 1.68. Now, explain why the other solutions can't be directly evaluated in the calculator. Because I don't have a log base 2 button or a log base 0.08 button. So to summarize this, what do we know? A calculator can evaluate logarithms in base 10, but it can't evaluate logs in other bases. But you can still use a calculator to solve any exponential equation, and I'm going to show you how. Okay, now, the first step would be you have to take the log of both sides. So I'm going to rewrite this as the log of 2x equals the log of 20. Now, I didn't say a base because we're assuming the common base here. Well, my next step is exponents inside logs can change to multiplication outside the log. So I can move my x over to the front of my equation, right? So I have x times log of 2 equals log of 20. Now, guys, I want you to think for a minute. If I were to give you the problem of 5x equals 25, and I asked you to solve that, you would all tell me to divide by 5, right? So if I wanted to solve for x, what's over here with the x that I need to divide by? That would be correct, the log of 2. So what I'm going to do here is I'm going to divide by log of 2. So you see now that I have solved for my x, and I know that x is going to equal whatever the log base 10 of 20 is divided by the log base 10 of 2. And that is something that I can put in my calculator. And if you were to place that in your calculator, what you would get is 4.321928. And then to check that, I would simply plug in my calculator, what is 2 to that power, and I would get 20. I actually would get 19.999999869. But it's approximately 20. So yes, it did check out. So let's go over that with the next example. So I know that the first thing that I have to do first is take the log of both sides. So I'm going to write them both as log base 10 of 0.8 to the x power equals log base 10 of 4. Well, then I want to bring my x to the front, which I can do because of my log property. And then I want to solve for x, which means that I have to divide by log 0.8. And when I place that in my calculator, which I can do now because they're in base 10, I would get negative 6.212567. And I would check that, and yes, it would work. Okay, now let's go to the next page. Okay, now we're looking at the next page. I know for each exponential equation below, I want to rewrite it in logarithmic form, which is going to be step A. And then I want to solve the original equation algebraically by taking the log of both sides, which is B. And then I want to evaluate the systems on the calculator. So my first step here would be to rewrite it, correct? So that would be log, that's my base. So I know it's going to be log base 6 of 104. My argument equals x. So if I rewrite that, what has to move? What do I know? That I'm going to have log 6 of x equals log of 104. And then I know that I need to just solve for my x. So I bring my x to the front, and then I divide by log of 6, and what do I get? 2.592. Okay, now let's do the same thing for the second one. So first thing I need to do, A, is solve the original equation algebraically by taking the log of both sides. So that's going to give me log of 1.5 of 22 equals x. Well, then I'm going to rewrite it so that I have algebraically, I'll have a log on both sides. So what do I get there? I'll have the log of 1.5x equals the log of 22. And then I'm going to bring my x to the front, and then I'm going to divide by, that's correct, 1.5. And that'll give me 7.623. And then I'm going to do the same thing on number 3. So take a moment and copy this down. And on number 4. And because this works every time, this establishes a rule for me. And we're going to talk about that rule in just a moment, which will allow me to make shortcuts. So how are they related? Answers may vary for what you think it is, but the answer is both expressions solve for x. In the calculator expression, the original base is always in the denominator. So because of that, we get the new change of base properly. Now, you probably remember that Miss B on your log property sheets. Let me show you what that looks like. This sheet right here, I told you, or most of my students, to at the bottom, go ahead and put an asterisk because there was another rule we were going to get. And today, that is that rule. So you want to make sure you have the rule of the change of base property. Log base B of n always equals log of n divided by log of b. So now with the calculator, I want you to use this property to evaluate your expressions. So instead of going through all the steps we went through before, you can simply say, okay, I know that I'm going to have log of 32 divided by log of 8. I know where that's going to change, so I don't have to go through all the steps above. Log of 32 is going to divide by 8, and I'm going to get 1.66. So what about number 6? Log of 1 divided by 49 is going to be divided by log of 7, which will give me a negative 2. Then I'm going to have log of 512 divided by log of 16. Then I'm going to have log of 0.03125 divided by log of 4, which will give me a negative 5/2 or a negative 2.5. Okay, guys, what this sheet shows you, take a moment before you write all this down, is that once I rewrite each expression, like I did right here, using my common log, I can also plug it exactly like that in the calculator. So once I go to my Y1 and plug it in the calculator, I now have the ability to graph a logarithm in my calculator. So how would I plug that in my calculator to graph it? That's correct. I know it would be log base 10 of x plus 4 divided by log base 10 of 2. So now I can use my calculator to get an accurate log graph. Okay, now based on what we did, guys, I want you to take a shot at the last page, 18 through 26. And the last one says bonus. I definitely don't expect any pre-AP students to come to class without that one worked. So take a shot at those. Have a good evening, Miss Buse. See you tomorrow.